So let's look at the following example that deals with a completely inelastic collision. So let's suppose that a bullet of mass 50 grams is traveling vertically upward when it hits a block of mass 1.5 kilograms. Now the bullet remains inside the block as it travels up to a certain maximum height. So we want to calculate what this maximum height is, knowing that the velocity of the bullet right before our collision takes place is 300 meters per second. So we break this problem down into two steps. In step one, we use the conservation of momentum to calculate the velocity of the block bullet system right after our completely inelastic collision takes place. And then in step two, we use the velocity and the conservation of energy to solve for the height. So let's look at step one. So right before the collision takes place, we have the block with mass 1.5 kilograms that is stationary, and a bullet with mass 0.05 kilograms that is traveling upward in the positive direction along the x-axis with a velocity of 300 meters per second. Now after our collision takes place, we have one object, and that object is composed of the bullet as well as the block. And together it has a certain velocity, v prime. So we want to calculate what v prime is. So let's use the conservation of momentum. Why? Well, because we have a completely inelastic collision. So only momentum is conserved during our collision. So the sum of the momentum of our two objects before the collision is equal to the sum of the momentum of our two objects after our collision takes place. So M1 and M2 are the masses of the bullet and the block. V1 and V2 are the velocities of the bullet and the block before the collision. And V1 prime and V2 prime are the velocities of the bullet and the mass after our collision takes place. So notice that after our collision takes place, we have one system composed of two objects, the bullet and the box. So the velocities of the bullet and the box after our collision takes place is exactly the same. So we can replace V1 prime and V2 prime with simply V prime. And that's exactly what we do. Next, notice that before the collision takes place, our object, the block, is assumed to be stationary. So that means V2 is 0. So this entire term goes to 0, and we take out V prime at the left side of the equation. And now we solve for V prime because that's what we're looking for. We want to calculate the velocity of our bullet block system. So V prime is equal to M1 V1 divided by the sum of M1 and M2. So M1 is 0.05 kilograms, V1 is 300 meters per second, and 50 grams, so 0.05 kilograms plus 1.5 kilograms is 1.55 kilograms. So we plug this into the calculator and we get approximately V prime is equal to 9.7 meters per second. So this is the velocity of the system, the bullet block system, at the moment right after our completely inelastic collision takes place. So now in step 2, we have to realize that the block begins at some position. Let's say it begins on the x-axis at the ground where the height is 0, and eventually it will end up at some height, at some final height where its velocity will be 0. So initially the velocity is 9.7 meters per second, and at the final position, the maximum height, the velocity is set to be 0 meters per second. So Notice the only force acting on our block when the block is moving upward in the positive direction along the y-axis is the force of gravity. And because gravity is a conservative force, we have conservation of energy. So that means the sum of the kinetic and potential energy before is equal to the sum of the kinetic and potential energy after. So notice that H1 is 0 because at the bottom our H is assumed to be 0, so this cancels out. And notice the final velocity, V2 of the object in bullet system after it reaches a maximum height is 0. So this term also cancels out. And notice the m's appear in every single term. So we can divide the entire equation, both sides, by m. And we're left with the following result. 1/2 V1 squared, V1 is what we found in part 1, is equal to G, a constant, times H2, the maximum height that we're looking for. So now we simply solve for H2. We see H2 is equal to, so we bring G to the left side, V1 squared divided by 2G. So V1 is 9.7 meters per second. We squared that and divide by 2 times 9.8 meters per second squared, and we get approximately 4.8 meters. So our block bullet system goes up to a maximum height of 4.8 meters when the bullet hits the block with a velocity of 300 meters per second.